Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at Sandrini Elementary School with Science for Kern, and we are here to... Do
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we're glad that you joined us today. If you have a math question and you'd like to call it in and have us help you out with that question, give us a call if you're here in Bakersfield. The number is 636-4357. Even if you're in San Luis Obispo, you're welcome to give us a call. The number is toll-free, 866-636-6284. You can even email us your math question if you happen to have that. dothemath@kern.org. You can watch the show online, dothemathonline.net. And of course, if you are at all on Facebook, Instagram, Twitter, or YouTube, you can catch us there as well.
All right, well, you know what? We did take care of some email questions, and I think one of them was one of your students, as a matter of fact. So always remember, if you need to email something in, preferably do it on a Monday, Tuesday, or Wednesday. If you do it on a Thursday morning,
right, going to be a little
while. Fine, but it's going to be a while until we can get back to it and address that on the program. Right. Anyway, we do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. We do have a very special guest in studio. We'll meet that young lady in a little bit. And word has it, she's going to be conducting class in here a little bit later on.
It's a good thing. We all need to learn a few things.
That's right. New ways to see things, and always an adventure in here when we have students in here.
That's right, no doubt.
Anyway, we'll be going out and checking out the students at Sandrini Elementary. We do have a phone caller to get to, but before we do any of that, let's first take a look at today's Math in the News. Now, before we get to the Math in the News today, I almost forgot. Welcome back.
Thank you.
Tell
us back again.
Briefly about your trip, where you were and what you were doing.
There's always somewhere to go, but one of my favorite trips that I get to make each year is I get to go to a Texas A&M football game. And the stadium, a little math for you there, the stadium holds 105,000 people. It's the biggest stadium in the state of Texas. And it was almost full the day that I got to go. But it's a heck of a place to be, to have all those people for the same
home
purpose.
Of the 12th man, right?
Home of the 12th man, that's right. So
they
really
tradition at College Station.
Yeah.
Right?
Yeah. And it's great. They really do. The fans really support the team, and the team really relies on the fans to be part of the game. It's really fun.
And they've had a good year thus far.
Yep, so far so good.
So they're rolling right along. Oh, rolling. Not as well as the Tide, though.
Funny how that worked. Yep.
But I did say, I mean, we'll let you bring, because they are an SEC team.
Right.
And they are competitive, and they are a force in the SEC. So, but it was a good time had by all.
It was great, yeah. Wonderful place to be.
There you go. Well, as I was going through the newspaper today, I found some of the problems that sometimes kids and adults work on, and they're the little logic puzzles and things like that. So a lot of them are, you have the classic crosswords and word puzzles, the scramble up the letters and stuff like that. But there's some that are specific to math. So one of them is Sudoku. And this is a game where a lot of kids are familiar with this right now, and adults are as well, where you can make them as complex as you want. And this one is rated only 2 out of 5 stars. So this one's a fairly easy one to work on. But what you want to do is you want to have in a row the numbers 1 through 9 without being repeated. Right. In a column 1 through 9 without being repeated. And in the 3x3 square 1 through 9 without being repeated. So you can see how this works a little bit. And here's the solution from yesterday. And if students haven't played one of these yet, they're pretty fun to try out, you know, for the first time and
Yeah.
see how they go.
I think I'd want to start off with the one that only has one blank space. Then I can move up from there.
Hopefully you will. So here's another one. Ken puzzles. Now, have you done one of these at all?
Oh, interesting. I've never seen a Ken puzzle before.
No. Oh, good. Good thing we brought one in today. So, it says the logic puzzle that makes you smarter. Well, of course it does, right? So, up on the top, we can see right here, it says 20x. So that means you're going to multiply to get 20, and you have to use 3 numbers in here, okay?
Okay.
If this is all by itself with a 1, you know that the digit 1 is going to go in that box.
Okay.
All right?
Gotcha.
So down here you can see, all right, we've got a 6. So you know that the number 6 is not going anywhere else in this row and nor anywhere else in this column.
So has it got to be 1 through 6 in each row and 1 through 6 in each column?
That's what you're doing.
Okay.
Okay. So, and then I was like, all right, so it takes a little bit of time. And I figured out there was one that wouldn't take much time at all based on how you look at it. So let me make sure that we can get this all in there. And let's take a look at this logic puzzle. So it says, in what parking spot number is the car parked? So you can see that there's a car parked and it's covering up one of the numbers. So you take a look at the numbers, and what I'd like you to do is take a look at this, because this obviously doesn't take as long as the Sudoku or the Ken puzzle.
Right.
Because you just have to figure out what number is. And we'll get to our guest here in a moment. But for the meantime, the both of you can confer quickly on this and see if you can figure out what parking spot that car is over.
Any ideas? Usually we would look at that and try to find a pattern, right?
Yes.
And so if you could find a pattern between one number and the next, that would be wonderful, especially a mathematical pattern. You could figure out maybe we're multiplying as we go along from left to right. Maybe we're dividing, maybe we're adding, subtracting. However, I would suggest that maybe we need to look at that picture in a different way.
Yes.
So how would you look at it right now?
What are the numbers
So
that
what are
you
you
see
thinking
there?
of?
As you look at those numbers, what are the numbers that you see?
I see that there are 2, well, since there's 1, 2, 3, 4, 5, 6. Since there's 6 spots and 2 of the spots have a 6 in it, that's one way, and
Okay.
3 of the spots have 8.
Good call.
So 6 times 3 is 18.
Interesting. I like that. We're definitely working with some numbers there.
Right.
It's good.
Nicely done. Now, as Scott was saying, and I'm glad that he mentioned this, is because you want to think about looking at it a different way,
Yes.
right? So
watch
if
this.
I
Are you
do
ready for
this,
some magic? It all becomes a lot more clear now.
what number is missing now?
87.
There you
there
go.
you
See, it
go.
took no time at all, right? So even though it was presented one way, you can look at it another way, and then you can see how quickly that one can be solved. And that is today's Math in the News. Some of the logic puzzles that you can find in the newspaper and periodicals and things like that.
Keeps you thinking.
That's right. 636-4357 is that phone number. We do have phone tutors available until 5:30. In studio with us, we have Nidhi. And how are you today?
I'm good.
Why don't you let everybody know where you go to school and what grade you're in?
Well, I am in Stockdale Elementary and I go to 6th grade.
And how long have you been at Stockdale Elementary?
I have been there since kindergarten, actually.
Since kindergarten.
Since kindergarten.
Wow. So next year you're going to be out.
Yeah, sadly.
Okay, so it is going to be a little sad.
Yeah.
What do you think the one thing is that you're going to miss the most about being at that school since you've been there for 7 years now?
Well, I would say the good education, because most schools focus more on health and others. They forget the main purpose of schools is the education.
Well, there you go. And you know what? Because I have worked with you occasionally, and I know that you are well educated, which is why I'm putting you to work extra hard today.
Oh my.
Oh, my, indeed. So, over to the board, young lady.
Okay.
There we go.
This is going to be a fairly easy one for you.
Okay.
Okay? On the board, I would like you to write the number 4 over on the left. And leave some space and write another 4. Leave the same amount of space, another 4. The same amount of space and one more 4. And after that 4, put an equal sign. And I would like you to choose a number between 1 and 10.
Okay. 7.
Put a 7 at the end. Now you must use those 4 4s.
Yes.
You can put any operation symbol you want in between there. Okay, so you can use add, subtract, multiply, divide, parentheses, whatever you want, so that the 4 4s equal 7. Are you good for it?
Yes.
Go ahead and give it a try.
Oh, going big real quick. Okay, 4 times 4 is 16.
Yes.
All right, keep going. We got to get back down to 7 somehow.
And you can always erase if you need to.
Yeah.
So
we
it's
may
not like you have
do
to
that.
stay
That's
with the
okay.
signs you have right now.
Good. So we got 4 times 4 is 16, plus 4 is 20.
Yep.
Can you do something with the last 4 to get back to a 7?
No.
Ah, too bad. You can also use parentheses, just so you know. Okay. So if you keep thinking about this, think about a little bit what we want to do here. Think about how you would get a 7. What's an easy number to get when you have a couple of 4s? What's an easy number to get to? 16 is one of them. What's another easy number to get?
8.
8. So we definitely
Yes.
know we could get 8, right?
Yes.
If you had 8, what would you have to do after that?
If I had 8, I would have to subtract 1.
Good. So here's our plan. Ready? We'd
Yes.
like to get 8. Can you get 8 at the beginning there? Gotcha. We've used those 2, right? Now, how do we use the other 2? Don't worry about these anymore. How do we use the other 2 4s to get a 1? Oh, I like it. Good. And then we want to take this quantity and that quantity and do what to them?
And then we would like.
Oh, I like what you did there. That's a really good idea. Yeah, so we have our 8, right? Just like you said, we have our 8 and we have our 1. And what do we got to do with them?
Gotta subtract.
That's it. Well done. Nice job.
There
I
you
like
go.
it.
Easy as that right there. Nidhi, nice work with the 4
Thank
4s.
you.
Hey, we do have phone tutors available until 5:30 right now. Out and about with Marylou at Sandrini and our friends from Science for Kern.
We are back live at Sandrini Elementary School, and we are with Michelle Roy today, Science for Kern Engineering Challenge. Hello.
Hey, good afternoon.
Now, you did a challenge last month.
Yes,
Can
we
you
did.
kind of tell us a little bit what that challenge was?
Last month, our challenge was to build a shade structure for the playground. You know, in August, you get hot on the playground. And so the students had a whole variety of materials in a bag. And they built a little structure that we took out onto the blacktop to see if the ice cube would melt faster inside the structure or outside. And guess what we found out?
Probably inside the structure, I would assume.
Yes, outside the structure, the ice cube was gone in 30 seconds.
Can you imagine? Yeah, in September. Yeah. Can you tell us a little bit about Science for Kern?
Yes. Science for Kern is a mobile lending library of science equipment sponsored by Chevron. And there are 9 Science for Kern units now. And actually 10. There's a brand new one called Waves. It targets 4th and 5th grade science standards. And teachers can log on to scienceforkern.org, make a reservation. The materials are delivered and picked up. And if they sign up, if the teacher's interested, there's a demo lesson that a credentialed teacher will come out and present in the classroom, and the teachers can turn the materials in used up. We restock and send them back out to school sites.
Does that fill up pretty quickly?
It does. It's wildly popular.
So teachers need to
Yeah.
obviously get on and
Yep,
check it
that's
out.
right.
Okay, can you give us a little bit background of what the challenge is today?
Our challenge today is we're going to be building some structures out of some very sophisticated building materials. We've got
My favorite.
Yes, we've got gumdrops and toothpicks, and the students have been given 10 gumdrops and 20 toothpicks, and we've been talking about shapes that might be good for construction, triangles versus squares versus diamonds, and maybe trying some of those out first to see which structure will hold a textbook.
Now, we have all 4th grade students today, correct? Yes, everybody?
Yes, we do.
Okay, I'll let you get on with it.
All right, so students, are you ready? Have we finished our planning conversations? Yes. Okay, terrific. I'm sure you're eager to get started building. So you may take your materials out of your bag and start constructing whatever it was you were talking about in your planning discussion. So, tell us a little bit about your plan.
We're trying to do a triangle to each shape for the book for it could stand on.
Okay, so one triangle, or how many triangles do you think you'll have?
Two.
Right, 2 triangles. Will your triangles be separate, or will your triangles be connected to one another?
Connected.
Okay, is that going to be your first try?
Yes.
All right, be interesting to see what happens with that. So ladies, what's your plan?
We're gonna do like a triangle so we can put the book on top.
Okay, so like just one triangle like this, or are you going to have multiple triangles put together? How's it going to work?
Multiple triangles.
How are you going to connect them?
Because we're going to do is do that.
Okay, all right, we'll come back and we'll see how you're doing. All right, gentlemen, how is it going here? Tell us a little bit about your plan.
So we're gonna try to do like a square,
Okay,
and
one square.
one square,
Okay.
and then we're gonna do the triangle or something.
All right, so tell me a little bit more about that. What might that look like?
Like
Is it just going to be flat, or are you going to try to build up?
build up. Try to build up and make it flat.
So flat on the up part, or flat on the part that's close to the table?
Flat close to the table.
Okay, I can hardly wait to see how it turns out.
Now, these girls are doing something, it looks like they're building up a little bit here.
All right, so tell us a little bit about your plan.
Well, we're gonna build 2 squares and then stick them together so they can make a little house and stuff.
All right, so you'll have a square on the bottom and maybe a square on top?
Yeah.
All right, well, we'll see how that goes. Come back and check on you. So tell us a little bit about your plan here, gentlemen.
Try to make a square, but we're trying to make it stand fully, so we're gonna do something to sticks right here, right here, right here, right here, and right here.
Okay.
And we're gonna try to even it out so when the book is on there, it can balance and it won't go to one side and break it.
All right. All right, how about you, ladies? Tell us about your plan.
Well, we're making a triangle, and we decided that we'll place a book right here, and
Just on top of that?
yeah.
All right. How about you, gentlemen? Tell us about your plan.
We're trying to make a triangle, but it didn't work. So now we're gonna make a square building upwards.
Okay, so what did you try first?
A triangle. A rectangle.
You tried a triangle first, and
I
so
made
now.
a rectangle.
Okay.
A rectangle. But it didn't work. We didn't have enough.
Oh, okay.
So now we had to make a square.
All right.
Okay, so as they continue to work, they will keep on building. Now, again, the main theme is to hold the book, correct?
Right.
Structure to hold the book.
Hold at least one book. And as we go, maybe we'll be able to hold multiple books on our structure.
So they're going to continue working, and we're going to head back to the studio.
All right, thanks
job,
for that,
everybody.
Mary Lou.
Keep building.
Kids are working out there at Sandrini Elementary with Michelle and our friends from Science for Kern. 636-4357 is the phone number. Phone tutors are available most Tuesdays and Wednesdays throughout the regular school year until 5:30 in the afternoon. And for those of you calling from San Luis Obispo County, don't forget that phone number is toll-free at the bottom of your screen periodically throughout the program. All of the students that phone in from all of San Luis Obispo County will win themselves ice cream courtesy of our friends at Doc Bernstein's. And there's also a little contest going on between 2 schools. And we see those 2 schools listed right there. Those schools have been in competition since September. And they've been in competition for about a month right now. And if I'm not mistaken, I think Grover Beach has a little bit of a lead on them right now. But this contest will go until December, so they've got quite a few more weeks going on that. All right, Nidhi, you ready to work?
Yes.
All right, over to the board. We'll put the problem up under the camera so the kids at home can see this first. And it says, to solve this, it says y is equal to 2x squared. So you may want to write the problem
Yeah.
over here, so that way you've got it to work with. So y is equal to 2x squared plus 5x plus 2. And take it away.
We want to do all kinds of stuff with that, huh?
Uh-huh.
All right, so what's this thing called, first of all?
This is a quadratic equation.
It is, that's right.
Yes. So
So what's the goal? First of all, if no one's ever seen this before and they look at this and go, what in the heck? What is our goal to be able to do with this
our
problem?
goal is to get x and y and put it in the graph above that you can't really see. But
Okay, so we're going to be able to graph it. We'll get
Yeah.
up there in a minute. So we're going to be
Yeah.
able to graph it. And what
Yes.
will the graph tell us ultimately at the end of the problem?
it will create a parabola,
Okay,
which is a thing in a graph.
Mm-hmm.
But it would give us our x and our y,
okay.
which would help us because you see there's a vertex,
There is a
which
vertex.
is the top, like the top point or the most bottom point. It depends which way our parabola is facing.
That's true. That's a good
Yes.
point. And in a regular equation, whenever you see an equal sign, usually we're trying to solve for an x or a y, right? So what we'd like to know is what the x values are, and we're going to find that from the graph.
Mm-hmm.
So go ahead and get started here and see what you can do. Teach me how to do this problem here.
Okay. Well, first I was thinking of getting a perfect square from this,
Okay,
and to get a perfect square, you can't have this too.
true.
So I was thinking of taking that 2 out like this.
Okay, so you factored a 2 out of the first one, right?
Mm-hmm.
2 times x squared is 2x squared. Good. What else?
And I was thinking of doing the same thing but with the 5x.
Right.
So since since this won't go out evenly,
Mm-hmm.
we would put it in a fraction like this. And then don't forget the x.
Don't forget the x. That's right.
And then I was thinking, instead of putting this 2, because we want a perfect square, and we
Right.
can't get a perfect square with that 2.
Okay.
So I was thinking of closing the parentheses and adding the 2 like this.
Gotcha. So you just took a 2 out of these first 2 terms and not the last one.
Yes.
Looks good so far. What's next?
Next, we want to make this a perfect square.
Mm-hmm.
We have to get our last c. Well, because there is a little formula,
Yeah.
ax squared plus bx plus c.
Right.
So this is our ax squared, this is our bx, and we need a c.
Right.
And to make this a perfect square, we got to figure out a way of.
So
with
let's
5
just
upon
look at
2.
the part in the parentheses. That's exactly right. Okay, so what do you
Yes.
want to do with the part in parentheses?
Well, I have found this trick that if you by somehow multiply 1 upon 2 with the 5 upon 2, and then with that same thing with the you would get 5 upon 4. And then if you multiply 5 upon 4, and then if you square the 5 upon 4, you can get our c, and it'll be our perfect square.
Gotcha. So you took this one
Yes.
and divided it by 2, and then we're going to square it, right? So it looks something like this. 5 over 2, right? Divided by 2, or times 1/2, either way,
Yeah.
right? And that's where your 5 over 4 came from. And now you want to take that and square it, right?
Yes.
Am I doing exactly what you told me to do?
Yes.
And you're going to put that number right here at the end. Is that true? Okay,
Yes.
so can you figure out what is 5 over 4 to the second power?
5 over 4 to the second power is, let me just set the problem here,
Okay.
x squared plus, and I'm going to change this into 5 upon 4, and then 5 upon 2 squared is 25 over 4.
Okay.
So, over 4,
Gotcha.
and then the 2.
Okay.
Yes. And after this, we put it all together, and really, so there's a special way of doing this. So we have the ax squared, and since our a is equal to 1, we have 1 times 1 is a. So if we put both 1s over here, and then 25 over 4, if we multiply 5 upon 2 twice, 5 upon 2 times 5 upon 2, you get 25 upon 4. So if you do, actually, oh my.
Board doesn't like you there. That's all right. We'll have a little spot there.
Yeah.
It'll remind us that we're not perfect.
So if we get 5 over 2 twice, then we get that. Now if you multiply both of these, you can get, well, the 5 upon 2. So we figured out both of these are the same. So if we, I'll just do it over here, if we want to bunch it together, then our x squared turns into x, because we're gonna, to bunch it together, we need a square up top. So our x squared will turn into x, and then our 5 upon 2 will actually we'll get 5 over 4, because this other trick I learned is that if you do the divide by 2 and then multiply it, then you would get our perfect square by just putting this like that, like right over there.
Okay.
It's a trick. It's a very long process to learn this trick,
sounds like
and
it.
we don't have the time for that.
All right.
So afterwards, we can't forget about that 2. So just put that 2 over here.
Gotcha.
Now this is the way that we can get our x and our y, because we know that since this is x, if we subtract 5 upon 4, this would equal to 0. And right here we have that 2, so just going to put that over there. So if we get x is equal to negative 5 upon 4, then all we have left is this 2. So if we really get all of this out, we get y is equal to 2.
Gotcha.
So we got our
So hold on, right before you
and
do
our
that 2 part, right? I'm concerned about two
Yes.
things. First of all, you change your 5 over 2 to a 5 over 4, right?
Yes.
And you can't just go ahead and change things like you want to willy-nilly in a math problem, right?
Yes.
What you can do though is you can have 2 of those, right? You can have 5, or you can have 2 of these, 5 over 4x plus 5 over 4x, right? That gives you 10 over 4. 5 plus 5 is 10. 10 over 4 reduces to 5 over 2. So there really should be 2 of those in there, but I like how you brought it together here. The other part I'm a little concerned about is you just added a number in here, which is a
Yeah.
wonderful thing to do. I like that a lot. However, if you're going to add it in there, you got to
gotta-
take it away from the end, because we don't want to
Yes.
change the value of this whole entire process, right?
I actually
So what
forgot
is the
about that.
what is the number that you added in there?
25 over 4.
Right. Is it really 25 over 4?
No.
What really is it?
It is 25 over 2,
Aha, because
because this 2.
there you go, good for you. So you can't forget about this one. So if you distributed this 2, this is going to be a messy problem, but those are my favorite math problems in the world.
Yeah.
25 over 4, right, times 2, because we had
Yes.
that 2 out there, gives us what you said, which is 25 over 2, right?
Yes.
We added it here. So what do you have to do to the end of the problem?
Subtract
That's
it.
right. So at the very end here, instead of a 2, it's not going to be this 2, right? This would be way too convenient. It'd be super nice if it was like that, because we'd just be done. But we're
Yeah.
not done. We want to do 2 minus 25 over
4. I mean 2.
2.
Yes.
So can you work out that problem for us? 2 minus 25 over 2?
Well, I need a
You want a little more room?
Yeah.
We can do that. There's not a lot of stuff I can do, but I can give you more room.
Okay.
Okay.
So instead of doing 2 minus 25 over 2, I want to convert this 2 into a fraction
That's a good idea.
with a denominator of 2.
You're explaining that very well. That's exactly right.
Yes. So 50 over, no, never
Just change
mind.
the 2.
Yes.
Just like you said.
Change the 2.
So we're going to
then we
keep this
get
25 over 2. Going to keep
Yes.
that there. That's not going to change. But the
No.
2 is going to change to
4 over 2.
good for you. 4 over 2, and that's where the 2 comes from, right? 4 over 2 is the
Yes.
same as 2. All right, what's that answer going to be?
Then that answer would actually be a negative, and we would get 21 over 2. So,
Can you change that to a mixed number?
yeah, actually we can.
Of course you can.
Then we would get 10 over 1 upon 2,
Uh-huh.
which would be our mixed number.
Is this number exactly the same as that one?
Yes.
You sure? Would you bet $5 on it?
One little symbol you need.
Don't forget this part. There you go. That makes a big difference, right? A big difference. So
Big.
you have a y value. I like the fact that you have a y value. And way back at the beginning here, you have an x value too, right? You had an x right here. Negative 5 over 4. I'm going to make this into a point. Negative 5 over 4 And the other value you got for the y is negative 10 and a half, or you could keep it as 21 over 2. Tell me what this point is, and we'll leave this problem probably for now, but tell me what we actually found. What did we do there?
We found our vertex.
We found our vertex. That's exactly right. We found either the highest point in the graph
Or the
the
lowest.
lowest point in the graph.
Yes.
Do you know which one it is?
Yes.
Which is it?
It's the highest.
It is.
I mean, no, it's the lowest.
It's the lowest. How do
Yeah.
you know that?
Because I actually want to.
You want to go back up again?
Yeah.
Okay.
Oh my. In our original problem, our A is 2.
The very first number. That's right.
And I actually found out that if our A, which is 2, is positive,
Which it is.
then
What do you do if you're a positive person? Do you smile or frown?
I smile.
You smile. It's a positive number. You're going to get a big smile, right? If that happened to be a negative number, you'd be kind of down in a bad mood, and you'd give it a frown. That's so you can
Yeah.
remember that one. Just a little trick for you there. But that's exactly right. It's going to be a smile. It's going to go up and down, and the point you found is going to be the point right at the bottom.
Yes.
Okay, right at the bottom, and that's going to be the vertex there. We'll look at that a little bit later. Nice
That's
job.
right.
Well done.
Nicely done for the
Thank you.
beginning of that problem. We'll continue working with Nidhi in a little bit. Right now, we're going to take a sneak peek out at Sandrini again and see how they're doing with the Science for Kern challenge that they've got out there.
How are we going to do that, though?
And we can see that they're continuing their work with the toothpicks and the gumdrops out there. Each of their groups
Let's see.
working,
Oh, well, that's a great idea.
collaborating on how they're going to finally achieve. Ooh, there we go. We've already got some weight going on that one.
Oh, book's too heavy.
So we're going to check out with those guys in just a little bit. But also, something else that we want to bring up is that Chevron, one of the major sponsors for Do the Math, and for many years they've been a major sponsor of Do the Math, they also have a program called Donors Choose. And this is where teachers can apply to the program and kind of present what they would like to do in school. And then in order to get the supplies, Chevron would donate those through the Donors Choose program. And we had an opportunity to go out to Haven Drive and see what was going on with their Donors Choose program.
Haven Drive. Bulldogs. Good afternoon, Bulldogs. How are we doing today? Good to hear. Now we're here today with all of our wonderful guests. We have board members, we have media, we have community members, we have people from Chevron as well.
There's a lot of talent right here in Kern County. The students are really smart. They want to learn. They're eager to learn more. We want them to become leaders in Kern County, and this is one way we do that is by partnering with Donors Choose and getting teachers really excited about enhancing the environment for kids.
A lot of the times when we have STEM education, we don't have the budget or we don't have the technology. Donors Choose and Chevron makes it possible for us to receive those tools that we need to teach. They get excited. They love being hands-on and using all this software, all this digital stuff. We're getting 30 drawing tablets to do graphic design. They learn to design a product from beginning to end, and not only that, they get to print it in a 3D printer. Now, with these donations from Chevron, we're going to be able to create the design part of it. They are going to design the packaging, the logos, and everything that goes with their products. So they're going from beginning to end with the design process.
What you're going to hear is you're going to hear the waves, but I'm going to hit the second resonator and you're going to hear a wah, wah, wah sound. Ready?
The STEM is just one area that we focus in, but today what you're seeing is students are learning hands-on a number of projects.
We are actually introducing a lot of 21st century jobs, such as graphic design, industrial design, engineering, and it takes a lot of those skills for them to get a job in the 21st century that they're learning here.
So nicely done with Haven Drive and their Donors Choose project, and a big thanks to Chevron once again for that. Hey, you know what? We do have phone tutors available until 5:30. We have Nidhi in studio doing some work, and we're also going to have an opportunity right now to go check out our friends at Sandrini Elementary and see how the Science for Kern is going along. Oh, that's right. We do have to
We're going to fix
take
our
a break.
problem.
We'll do that right after this. Today we're at Piute Mountain School, home of the Wranglers, and we're here to... Piute Mountain School, and today we are with 6th, 7th, and 8th graders, and we're going to do a little bit of work on probability. So, how many of you in here have ever done anything with probability or can tell me anything about probability?
I've done, I can't really say anything.
You've done nothing with probability?
I have, it's just I don't really remember it.
Okay, well that's fine. What else do you guys know?
Probability is basically random. You cannot have a direct number and expect it. So probability, like marbles in a bag.
Okay, so if I had marbles in a bag and they were all different colors and I said, what's the probability of pulling out a blue one, what information would you need to know?
The numbers.
The number of what?
Of blue marbles and the others.
Right, you need to know the number of blue marbles and all of the marbles put together, right? So we have a desired outcome and the total number of outcomes that are possible, right? So what else about probability? I mean, when have you heard it, seen it, used it?
Last year.
And when was that?
We used it last year in 7th grade at the end.
Okay, so do you remember some of the activities you were doing with it, or?
No, it was just a lesson. And 2nd and 3rd grade, we did it.
So it goes way back, right?
Yeah.
When you first started, right? And then as you get older, you start doing things a little bit more with it and things like that, okay? Have you ever heard of somebody saying, oh, I have a lucky number? Do any of you have a lucky number?
Yes.
What's your number?
29.
29. Any other lucky numbers? Nobody else has a lucky number? Why 29 then?
My birthday.
There you go. So born on the 29, 29 is his lucky day, all right? So sometimes you'll hear people, if they are rolling dice, okay, and they want to go, oh, you know what? My lucky number is going to be a 7. Have you ever heard somebody say, my lucky number is 7? Okay. Why do you think somebody would say, my lucky number is 7? Because a lot of people happen to say that.
Because they would more than likely just need a 7 to roll. They would probably need to roll a 7.
So they would need a 7. So they're thinking, all right, I need a 7, so my lucky number is going to be 7, right? So what we're going to do is we're going to take a little step into this and find out why people always say, my lucky number is going to be 7 if I have 2 regular dice to roll. And we're going to take a look at this in just a little bit. So you guys ready to go?
Mm-hmm. Sure.
All right. Here's what I want you to do. I want you to, first of all, you're going to take 2 dice. All right? And what you're going to do is you're going to roll them, and you're going to go 1 and 1. Now here, we're going to add the dice always. You're always going to add them. Okay? So on your paper, you're going to go 1 plus 1 is equal to 2. All right? So you can go ahead and write that since I rolled the dice for you right there. All right? And why don't you roll your dice and see what you get. All right, so you get 6 plus 5, so you're going to write 6 plus 5 is 11. Okay, so what I want you guys to do is you're going to roll 10 times. Each person is going to roll 10 times, and you're going to put your outcomes for those 10 rolls on the paper. Everybody good?
Sure.
All right, go ahead and start rolling.
I got it twice.
I got it same twice.
Wow.
With the same numbers.
All right, well, the kids are rolling dice right now. They're doing it 10 times. We're going to figure out what their outcomes are. And when we come back next time, we'll see what they did and if we can get 7 to be a lucky number. And again, a big thanks to all of the staff and students at Piute Mountain Elementary School. Are you ready to do more work?
Sure.
All right, well, stay ready because right now we're going to go back out live to Sandrini Elementary and visit with our friends from Science for Kern.
We are back live at Sandrini Elementary, and I am with Michelle Roy, Science for Kern Engineer Challenge. Now, when we had gone off of air, you discussed with the students about their structures because a lot of the students started doing structures similar to this.
Yes. And we quickly discovered that this sort of structure, whether it be square, triangle, diamond, you put a book on top, yay, mission accomplished, right? So we've been working on going three-dimensional, going up, and maybe repeating the same shape around the sides, up on top. As we go around to visit the students, we'll see that some students actually combined multiple shapes into their structure.
So they took, obviously, squares and triangles and
Correct,
whatever they needed to do. Okay, so let's go ahead because we are going to do a pre-test, correct? Are you all ready to test out your structures? Okay, why don't we start over here this time with these?
All right. So grab the book. Can you reach over and grab that book? And let's see how it goes. You ready? All right, here we go.
1, 2, 3.
Oh! All right, so what do you think you might change as you rebuild? Any thoughts yet?
Can we go back to, you guys had done something different. I noticed you changed it in the last few minutes. What did you have in between? You had what?
An X.
An X. Do you think you might want to go back to that and try that again? Okay, you guys keep working. Let's
Keep
go on
working.
to the next group.
Let's see over here. All right.
We tried a new method that didn't work, so we ended up doing a square. We knew if we built it too high, it would have leaned to one side.
All
so
right.
we're trying to build a rectangle that's low.
You want to put this on top and see what happens?
So it looks like you guys have a rectangular prism.
Yeah. Let's see. It's going to hold. Oh. All right, so what do you think you might do differently?
I think we're going to try to make it sturdy on the outside so it doesn't fall just to one side.
Okay. All right.
All right, you
Well,
guys
good luck
keep
with
going.
that. All right, ladies, are you ready?
Yeah.
All right, here you go.
Now, you guys have a triangular prism that you've created.
Look at this. Let's show the top. Check out the top of it there.
I did big books, but we just made it with gummy.
Okay. All right, well, let's see what happens. Let's see if that will hold the book.
Oh, no. I thought for sure that was
I was hoping that one would.
Hey, it looks 3D.
Yeah, almost.
That's
All
what
right.
I realized.
Let's see the book.
All right.
All right,
Now
how's it
move
going
on,
over
ladies.
here?
Keep going.
We're still kind of working on it.
All right, you want to try? Here. Let's test what you have. Let's see if anything needs to be changed.
Oh, it's slowly going. It's slowly going. It looked like it had some structure there, and then it slowly
I
started
thought
going.
for sure, since you hadn't gone very high, that might hold the book, but no. All right, good luck, ladies. Let's see if you can modify.
Wow,
And
look at this. This is way different.
all right, so let's do the top of that one too. All right, so you want to here? Who's going to test? All right. Let's see. Fingers crossed.
Is it holding?
Did it squish?
It's squish, but
Is it going?
It's going.
Is it squishy?
Did it squish? Oh, just a little. It leaned over, didn't it? A little bit. Here. Almost. You guys are getting
You're
somewhere.
close. You're close. I'd work on where that's squished at.
Are you ready? All right.
I like how you have the triangle in the center.
Yeah, check that out. There's this triangle here. The gumdrops touch it.
Yes, we
All right.
did.
All right.
No! It just slided on.
Okay.
All right. Well, let's see if we can't Can you make it level, flat on top, maybe?
Okay, while you guys do that level, let's test these ladies over here.
All right.
And you all have a triangular prism and kind of
We're gonna make sure it doesn't like.
All right, let's see what happens.
Is it in the center there? Oh, so close. So close.
Almost.
It didn't completely go all the way down.
If we have another one, it's gonna work.
So think about how you might change it so that it doesn't cave in. Because it looked like it stayed together, didn't it? It didn't just completely smush like some of the other groups.
Okay, before we go back, gentlemen, you ready to test one more time?
Yeah.
You want to try
I
it?
wanna
Okay.
see what happens there. All right, here you go. You do the test.
Is it go? Oh, it's slowly going. Okay. All right. So as all the teams continue to work, we have a little bit more things that we need to adjust. We're going to send it back to the studio, but when you come back to us, we're going to have another final test for you. So back to the studio.
All right, nicely done for that. We had a lot of fun watching that over here in the studio. We do have phone tutors available until 5:30, and because Nidhi is doing some excellent work today, we're awarding you with a couple of things, and one of them is a meal courtesy of our friends at Grillin' Burger. So congratulations on that. And this is a place that is fairly new down on Gosford Road and a sponsor of Do the Math. So congratulations on that. You ready to do a little bit more work?
Sure.
So there's something you need to fix in that problem first, and then you can continue with it. And I'll give you guys about 5 minutes to do this.
Perfect, we can do it.
Okay.
So let's go back and explain where maybe a mistake was made. No, not even maybe. Where definitely a mistake was made.
Yeah.
So let's go back over here. We had this part here where we had 5/4. We had that in the second power, and what did we forget to do?
We actually forgot to multiply this by 4
That's right.
and get 16.
We forgot to square both of them, right? So
Yeah.
it's 25/16. So instead of this 25/4, we have 25/16. So
16.
that means that our y value is going to change a little bit because we got to go down here a little ways. I like your 25/16. Now when you go, because we added that in, we have to go back and subtract it over here, right?
Yes.
It's not going to be 25/2. It's going to be 25/16, but not, hold on, not even really 25/16. What's it going to be?
It's going to be 25/8.
That's right, because we're going to multiply that times 2, right? So 25/16 times 2, right? And that makes it into 8. So there's a 25/8. All right, so now we want to do this little math problem here where it's 2 minus 25/8. Okay? And we were pretty close to doing that earlier, right? You had this is okay. Well, we might want to change that a little bit too, right? That's not going to work out so well. And now this is no longer 2.
This is 8.
It's what? Yeah, it's 8. So I got that part. But you still have a 2 there, and you probably want to make an 8 on the bottom. Would you agree?
Yes.
Okay, so what's going to be on the top if you have an 8 on the bottom?
We would get 16 upon 8.
Nice job. 16 divided by 8 is 2. All right, so we have a little bit more work to do here. Probably that whole part can just be gone, right? Hooray for the palm of the hand. And it's all gone.
Yes.
All right, let's continue now. I'm pretty sure we're on the right track now.
Okay. So 16 minus 25/8 is the negative sign first. And we would get 9 upon 8.
Gotcha. All right, so we have a new point here. This takes a little bit more intricate erasing. -9/8.
Yes.
Okay, so we still have this point. Can you remind us again what the point actually signifies on the graph?
The point is actually a vertex.
Okay, it's the
And
vertex.
Yeah, and it's going to be the most low
The
point.
lowest point on the whole thing. That's exactly right.
And you guys have 3 minutes.
All right, we can do this. If you're going to graph this point, would you like to change those to mixed numbers, or are you going to keep them in the form of an improper fraction?
I would like to change them into mixed numbers.
All right, let's do that. Here we go. So we're going to come up with a new point here. Give ourselves a little bit more room. Maybe I can even make that a little bit bigger. We're going to do down here. We're going to come up with a new point so we can graph it. We know they're both negative, so let's not forget about that part. What's 5/4 in a mixed number?
1 and 1 upon 4.
Good for you. Oops, not 4/4. I'm going to do a 1/4. All right, what about -9/8? What's that number in a mixed
That's
number?
going to be 1 and 1 upon 8.
1 and 1/8. Okay, you think we can graph that point on the graph?
Yeah.
All right, let's go back up here. -1 and 1/4 and -1 and 1/8. There's a graph. Can you put that on there? I'm going to write that one more time just so you don't forget. -1 1/4, -1 1/8.
Okay, so this is the x, and this is the y.
That's true.
Yes. So since that's our x, and this is negative, I'm gonna put it on the negative side.
Okay.
And it would be -1 and a little bit. So it would probably be over there.
Okay.
Yes. And our y is also negative, so that's gonna be 1 1/8. That's gonna be pretty hard. Let's say right over there.
Yeah, somewhere around there. So yeah, we want to probably get rid of this one so we're not too confused, right? But there is the vertex. That's it. All right.
Yes.
So what's the graph going to look like from there?
Well, we have to plot more x's and y's, and then we would get more points.
There's more points. So what could it look like? Give us an example of what it could look like.
It could look like something like this.
Good for you, and that's the bottommost point, right? Could the graph look like this? Would that work also? It may not be the exact graph, but it would certainly go through the same vertex, right?
Yes.
And you could even have a nice little skinny graph like this. Would you agree? So the key is, if you were going to finish up this problem, we would love to know exactly how wide or how skinny it is, and there's all kinds of tricks we can do that. Unfortunately, I think class for this project is over for the day. Nice job on the day, though. I think you did good work on that.
Excellent work on that. I don't know where you got the buzzer.
We got the buzzer, man. We worked hard for that buzzer.
Right there. All right. Hey, you know what? We do have phone tutors until 5:30. We have an opportunity to go out one more time and visit with our friends at Sandrini Elementary and Science for Kern.
We are back live at Sandrini Elementary School with Michelle Roy, Science for Kern. And after we went back to the studio, Michelle, you gave all the students.
I gave the students a gift. They were so excited. 20 more toothpicks and 10 more gumdrops.
So for them to continue on.
For them to see if that made a difference in their construction. We've also changed our changed to a hardback book too. That's a little smaller and not so floppy off the sides.
And
to see if that might make a difference too.
What I noticed right off the get-go is that everybody tore theirs completely apart except for one group.
Right.
And they completely restarted from scratch.
Right. They decided that it was time to start over. And we have been talking during the break too about triangles, and how in construction that triangles are a very sound construction shape.
Okay, so I think we might have a few groups. These ladies over here, let's see if they're ready to test. Because you were one of the groups that did not completely tear down, correct? You kind of kept with your same design. What did you do when you were given more material?
We just put more triangles on the outside.
Okay, but I noticed something because yours is different than everybody else's. Everybody else's, they're using the full toothpick for the length, for the width. But you didn't. What did you ladies do?
We cut the toothpicks in half.
And what difference do you think that's going to be by doing that?
We have more toothpicks.
And how is this structure different than what you tried during our last segment? How is this one different?
We put more triangles.
Oh, okay.
And then you also did something with the drops, right? What did you guys do with those?
We tear them apart.
Why?
To make more.
Okay, you ladies ready to test to see if this is going to work?
Who's going to try?
You can do it. I did it. Okay.
All right, are you ready? Oh! I was for sure it was going to work.
Okay, what do you guys think you can do? Because obviously it's going this way from the weight of the book. What do you think you can do to help that? Okay, you ladies keep working, okay? Gentlemen, are you ready?
No.
You're not ready yet. Okay, I think the group over here, though, is ready. Gentlemen, you ready to test?
All right, tell us how this structure is different from what you had before.
So we made a cube. We put a triangle shape on top of here, and then we added another triangle right down here.
But then it just started like going up, so it wouldn't stay on the ground.
Okay, so what do you think that having multiple toothpicks as your cross beams?
Get extra support.
All right, all right. Who's going to try? All right.
second
gonna work?
It was kind
Oh.
Whoa! We just need it on here, Keelan.
So what do you think you need to do to get the structure to stay up and not squish?
Make a triangle, a cube, a rectangle.
Back to a cube?
A rectangle.
All right. Well, let's see what you can do and we'll come back.
Wow.
Oh, wow.
Look at this.
Look at that. All right, so tell us about how this structure is different from what you built before.
Okay, when we first built, we started thinking we started doing like a square and stuff, but we realized when we put the book, it fell off completely. So we just started thinking, and then we think of a tall tower and see if it would work to stick on. Well, not stick, but the book would be on there.
Okay, so what do you think? Should we test it this way? Or should we test it? Is it stuck to the table? I don't want to break it. Or should we test it this way?
This way.
What do you think?
This way.
Do you want to do anything to it before we test?
No,
You want to try? Or do you want to test
that way at this way.
the sky? This is like a skyscraper, huh?
Yeah.
All right. You want to try this way?
Yeah.
All right. Should we straighten it up? Straighten it up before we put the weight on top? You want to try? All right. Do you think it makes a difference if you put the book on this way versus this way?
Yeah.
What do you think? Which way are you going to try it?
This way.
All right, let's see.
Try the other way. Try the other way.
Oh, almost. Yeah, let's see what happens. Let's see what happens. Put it on the other way. Almost. All right, keep working.
We do still have more, and we are out of time. So what's going to happen is if you keep an eye after the show is over, go to our Facebook Live, and the students are going to continue with testing their structures. And again, Michelle, thank you so much. Always a pleasure.
It was lots of fun.
We
all learned something today.
Yes, we did. All right, so we're going to send it back to you at the studio.
All right, thanks for that, Marylou, Michelle, and Science for Kern. Hey, we do have phone tutors available until 5:30. A special thanks for Nidhi for coming in. And you now are going to have a uniform.
Oh my. Okay.
Have you ever had one before?
No.
This is your first uniform? Well, we're going to put it right over here. And this is your Do the Math uniform because you are now an ambassador for Do the Math. You know what you have to do now?
No.
Tell everybody about Do the Math.
Okay.
All right, so you're going to wear this for about a week, and then you're going to come in, and we're going to give you one of the button-down shirts because you're going to be hired as a tutor soon.
Well, that's
Are you good with that?
Yeah.
All right. Well, thanks for Nidhi for coming in. Thanks to the staff and students out of Sandrini Elementary. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.